In this video tutorial, we're going to show how ADAPT treats slabs in terms of precedence for the reference of base reinforcement. And we're going to go ahead and use ADAPT Builder. This is version 2019. The same functionality is used in version 20 and also previous versions of the software. So we're going to make sure we have FloorPro selected. And what we're going to do is by default, the default thickness of a slab in this case is 8 inches or 200 millimeters in SI units. So here we're opened in US units. If we go to model, and let's say we model a slab of 8 inches thick, and in the same instance of use of that tool, I'm still actively engaged in that tool, I'm going to just change the properties now to 24 inches. So we'll say that there's another slab that's 24 inches, and we're going to say that that slab actually falls over here. Okay, so now we're going to actually draw the same general arrangement of slabs, and I'll say this is a 24 inch slab here. Now that's 24 because I've changed the thickness, and it carries the same thickness for every successive slab unless you change the thickness, or there's also a setting where you can always revert back to the default. But in this case, we're carrying the same thickness as it's changed. So that's a 24-inch slab. And now if I go back and say, well, I also need to draw an 8-inch slab, we're going to do that. And we'll draw in an 8-inch slab here. So we're going to draw this slab. Let's just draw like so. Okay, so we have two slabs that are essentially the same in terms of their geometry. If I take a section cut from the visibility tab, we can see there's this 24-inch step here, or it's I guess a 24-inch thickening, and then we have an 8-inch slab. And we want to add now bottom reinforcement. The bottom reinforcement, this is considered base reinforcement. It can be in the form of a mesh, banded reinforcement, distributed reinforcement. So if I go ahead and I select this slab, let's say I select that slab, and this is intended for the thinner slab. It's intended for the 8-inch slab. So I go ahead and I create a bottom mesh. Okay, and we'll do one here. We'll create a bottom mesh. And just looking at this, the user may think that the reinforcement is within the slab, but it's the way that the program categorizes the reinforcement in terms of cover and depth is dependent on the entry of the slabs. So this slab here, this was actually slab 1, and then we have 2, and then on this side this was slab 3 and 4. So on this side the rebar is referencing the lower level ID of the slabs entered. There's two slabs with ID 1 and 2. This is going to reference the 8-inch slab. Over here, because the thicker slab was input first, it's going to reference that slab. And if we look at a side view of this, we can see this references the 8-inch slab, which was input first in sequence in terms of ID. And here, this is referencing the thicker slab because it was input first in terms of ID. We could always modify the cover. I could select this bar, and I could use this option for cover to push this up into the slab or actually push it down. But one way to handle this might be to separate this. Because this passes through two different slab thicknesses and two different slab components or entities, it chooses between the two based on the ID. If I put a mesh here and then another mesh here, there's no need to choose between two different IDs. We have two unique entries of this mesh, and it offsets them properly. So that's one way to handle this situation. Now the next example will be banded reinforcement. This is really just grouped reinforcement. So let me just delete these two bars. If I take banded and I just put a bottom bar here and here, again, because it's passing through two different slabs, we get the similar condition. We get one that's referenced from slab 1, and then the other one is referenced from slab 3. If I go back and I pull this back outside of slab 3, for example, you can see it now gets referenced within the slab that it's contained within. So this is how bars are referenced in terms of their cover and their offset. The last example would be for distributed reinforcement. I'm going to say we're going to have a bar from here to here, and it's going to extend from this slab edge on the top down to the slab edge on the bottom. We'll do the same thing here. Okay, and again, looking at a side view, you can see where those bars are referenced. This only pertains to base reinforcement. If we wanted to design this slab, and we might have columns here, and maybe a third column. Let's say we have something like this, and along this column we're going to generate design strips. So we're going to have a strip maybe that's along here, along these lines, and we can always draw those in under floor design. I'll use the dynamic editor here to do this, and I can just draw in these columns, these strip lines here. I'm just passing through the supports. Okay, and then I would switch directions. Maybe we're going to do also this is a two-way slab, so we want strips in both directions, and we'll do Y direction also. Okay, so that's good enough for that. And I generate the design cuts, and I'm going to look at the Y direction. So in this case, we have a section cut that cuts through an 8-inch slab and a 24-inch slab. So the physical cut looks something like this. The idealized cut, that gets kind of converted into an idealized cut that would look something like this, where this, I'll call this B sub W, is this dimension, but we just center this width here on a center line of the slab. And when we design this section cut, we assume the greatest effective depth of the idealized section, which, if we're looking at positive bending, might be from here down to the location of our reinforcement, which is defined by the cover that we input, and then the bar sizes that we've input for the design. So the program handles this in design, and it considers the overall section geometry when we're designing as compared to when we're just specifying reinforcement as base reinforcement. In the other direction, in this direction, we have a section cut here, which is just a rectangular section of 24 inches, and then another of 8 inches. And the same thing, might happen here. This one actually cuts through at a really shallow angle on each thickness. So this one looks, something like this. Here we might actually want to straighten this support line out so we don't have that occurrence happening. But we would expect a rectangular 24-inch and a rectangular 8-inch. So the intent of the video really is to show how does the base reinforcement get referenced in the slabs, and that kind of carries on also into how does the program handle sections that cut through the slabs in terms of the design. If you have any questions about this, please contact us at adaptsupport@risa.com.